So, last 2 days we've been looking at the blood, the circulatory system of the body, and how that helps your body run. And now we're going to be looking at the respiratory system. And the respiratory system is what helps you also to breathe. The job of the respiratory system is to carry gases between the outside air and your blood. So, the respiratory system works together with the circulatory system to help your body run. So, we're going to get into the different parts of the respiratory system and how it best works to help you function. As we're working through this first section, the parts of the respiratory system, we're going to just be writing the definition of the vocabulary words down. Your respiratory system is at work whenever you smell, sing, talk, laugh, or breathe. Many parts of the respiratory system are coated with mucus. Mucus is a sticky, thick fluid that traps dust, germs, and other things that may be in the air. So take the time and write down that definition. And mucus is a thing that sounds a little bit gross, but and sometimes it can be, a lot of times you'll find it in your nose. So the mucus there, that is there to trap things in the air so that it's not going into your body. So it does have a purpose of being there. Air enters through the nose or mouth. Sinuses warm and moisten the air. With its hairs and layer of mucus, the nose traps dust and germs. So the little hairs in your nose, so the mucus in there, it's all there to trap the dust and the germs. Air passes from the sinus to the back of the throat and into the larynx. The larynx contains the vocal cords. So it goes from your nose and then basically down your throat is how that goes. So your sinuses are kind of right in between your eyes, and then it goes down to the back of your throat and into the larynx, where your vocal cords are. So right in here. The trachea is a tube that carries air from the larynx to the lungs. So, tube that carries air from the larynx to the lungs. So your trachea is about right here. If you push down, you'll feel it. It's a little bit painful. So like right in between, that is your trachea. So the trachea leads to two branches called bronchi that go into the lungs. So it kind of separates in the lungs. These tubes branch into smaller and smaller tubes called bronchioles. Asthma is a disease in which these tubes may become narrowed. So if you're a person who has asthma or knows somebody who has asthma, the reason that sometimes it can be hard to breathe is because those tubes are just a little bit smaller for people with asthma and can become smaller, causing it, making it a lot harder for them to breathe. So getting the definition for the bronchioles on there. So tubes into lungs is what you can write, is where it's going on with about the bronchioles. Tubes into lungs. All right, going on. The bronchioles end in clusters of tiny, thin-walled pouches of air sacs in the lungs. Air sacs are where oxygen enters the blood. So oxygen enters blood, carbon dioxide leaves. Like we talked about last week, carbon dioxide is the thing that we cannot have in our bodies in big amounts. We need the oxygen, we don't need the carbon dioxide to stay in there. Air sacs are also called alveoli. The diaphragm is a dome-shaped muscle that forms the bottom of the chest area. So if you're thinking on your body, right underneath your chest, kind of where your lungs are, you can feel the diaphragm. When the muscle contracts, it moves down and gets flatter. So how you breathe. Several muscles work together when you breathe. When you inhale, your diaphragm contracts and moves down, making more space in your chest. Your rib muscles may also pull your rib cage up and out. So that's why when you inhale, your lungs come up and out, making still more space. Air quickly rushes into the lungs and takes up these new spaces. When your diaphragm and rib muscles relax, they push air out of the lungs. Vital lung capacity is the amount of air that a person can blow out after a deep breath. The vital lung capacity for an adult is often about 3 to 5 liters. So when you take a big breath in, and that air you blow out when you're an adult should equal about 3 to 5 liters. So it's hard to measure just air out, but if you catch it, that'd be similar to like a liter of soda, 3 to 5 of those. So looking then just at the different parts. So your sinus right behind your nose, going down to the larynx, the trachea, and then it's just showing you the different parts inside your lungs so that it breaks into smaller parts, and then your diaphragm being at the end. So cilia are tiny hair-like structures on cells in the linings of many parts of a system, such as the trachea. Cilia help air by waving very rapidly. The waving pushes dirty mucus out of the lungs to the throat where it is swallowed. So just looking at cilia, what it is, it's tiny hair-like structures on cells and linings of the respiratory system. So again, it's just there to help keep everything clear. So just writing down, the diaphragm is a dome-shaped muscle, which if you think of a basketball or any kind of ball, that like overarching, so if you cut a ball in half, if you just had that dome part, so a little bit round. And then it says, when you blink, your diaphragm contracts and moves down. So if you inhale, you look like you're moving up, your ribs might be moving up, but your diaphragm is actually moving down. So when you inhale, your diaphragm moves down. All right, and then flip it over to the next page, getting oxygen to cells. The cells of all multicellular organisms need oxygen in order to get energy. So writing that down, always oxygen. We need oxygen to survive. All of our cells need oxygen. In insects, the respiratory system carries oxygen. Tiny tubes run through insects' bodies. The tube opens up at holes on their sides to let air in. In worms, the circulatory system carries oxygen. Their blood absorbs oxygen through the moist skin and carries it to all parts of the body. Your body is more complex than these organisms. People have both respiratory and circulatory systems working together to get oxygen to their cells. The respiratory system gets the oxygen as far as the tiny air sacs inside your lungs. The blood picks up the oxygen there and carries it to all your cells, all the way down to your toes. In the air sacs, two things happen at the same time. Oxygen leaves the lungs and enters the blood, and then carbon dioxide goes the other way. So what they're doing, oxygen in, carbon dioxide out. They kind of make room for each other. So the output of one system is the input of another system. When you hold your breath, carbon dioxide builds up in your blood, and your brain can make sense of this. Without making a decision, your brain sends a message to the diaphragm and rib muscles telling them to breathe. In this situation, we see several systems working together to make sure cells get oxygen. So as soon as you try holding your breath, your body starts sending messages to your brain to say you need to breathe, and your brain sends that message to your diaphragm, you need to breathe, to get that carbon dioxide out and to get that oxygen in. So in this last part, when you have a buildup of carbon dioxide, your brain sends a message to your diaphragm to breathe. And then you can look in here, it's just all the different parts of the air sacs, and these are just inside your lungs. It's nothing unhealthy, it's there to help you breathe. And it just works to get the carbon dioxide out and the oxygen into your blood. Looking then at our worksheet, this top part is going to be all of these from the top. So you should be able to match those up. On the bottom part, it's asking when you blink, your diaphragm contracts and moves down. That's, again, we talked about that going through. The one that I do want to help you through is number 6. The tiny hair-like structures on cells in linings of many parts of the respiratory system are called, and that's the cilia. That was one it's not a whole section in here, so it's a little bit harder to find in your book, but you can find about the cilia on page 71. All right, this last question we'll walk through. While sitting at your desk, you inhale an average of 19 times per minute. How many times will you inhale in 5 minutes? You can do a couple different things. You could take 19 plus 19 plus 19 plus 19 plus 19. That will give you one answer. You could also take 19 and just multiply it by 5. Either way, you'll get your same answer. Make sure that you show your work on there to get your answer. And then you are all done with lesson 2.